Lesson 7.2, first part, multiplying rational expressions. Yay! Now, I actually love multiplying and dividing fractions because with multiplying and dividing, you get to do all of that lovely canceling. So if you remember when we multiplied 2/3 times 6/8, right? We could cancel and say, oh, 2 will go into 8, and we got 4, and 3 will go into 6, and it's 3, and oh, and it's just 3/4. Easy sneezy. Well, same type of thing is going to happen here, okay? What we're going to do is this. Let me get out my handy-dandy little list of steps. So when we're multiplying rational expressions, here's what we're going to do. Step 1. Factor out each numerator and denominator. So just like we did in the last section where we factored out each numerator and each denominator, when we were simplifying, we're going to do the same thing. So multiplying is really just simplifying a lot of fractions altogether, is what it's going to end up being. So the steps are very, very, very similar. And actually, I didn't even rewrite them. I just kind of erased a few words and rewrote those parts in. So for multiplying, you're going to factor each numerator and denominator in your problem. Step 2, you're going to divide out or cancel any numerator with any matching denominator. So if you've got something that's exactly the same in any numerator, is the same as any denominator, you can cancel across, or as long as one is up and one is down. All right, you can cancel anywhere you want as long as one is up and one is down. And then the last step is just to multiply any remaining factors. Remember, you're going to multiply across the numerator by the numerator and the denominator by denominator. You're just going to multiply straight across. So let's just do some. Here we go. 9x over 5y times 15xy squared over 12. So step 1, factor out each numerator and each denominator. So 9 is 3 times an x over 5 is already reduced. So 5 times y, or 5 is prime. So it's already factored out. 15, you'll remember, is 3 times 5 times an x times a y squared is 2y's. All over 12. 12 is 3 times 4, and 4 is 2 times 2. So we've got 3 times 2 times 2. So then I'm going to get out my red marker because anything that matches. So that's what we've done now, is we've just factored everything out. It's exactly like what we did in the last section, except now we have two fractions side by side. So now we can match up any numerator with any denominator. So I've got a 3 here and a 3 here. So that will reduce. And I've got a 5 here and a 5 here. So those will cancel out. And let's see, I've got a y and a y way over here. Let's see. I've got x's the same, but they're both in the numerator. And 3 is the same, but they're both in the numerator. And 2 is the same, but they're both in the denominator. So that's all that I have that's the same. That's the same on the top and bottom. So now I simply multiply straight across. So 3 times x times 3 times x. So 3 times 3 is 9. Then x times x is x squared over 2 times 2 is 4. So there's your final answer. All right. I hope I left myself enough space for all of these problems. Oh my goodness. I will try to write smaller. Okay. Same thing here, but what we've got here is some binomials. So let's remember how to factor those. 2x is just 2 times x. 3x minus 9. 3 is in common with both of these, so 3 will come out. And then x is left on this part, minus 3 here. So this factored a 3 out of here, so it's 3, and then x is left here and 3 is left there. And then over here on the top, 5 will come out of both of these, but no x's. So 5 comes out, and I have an x left here. Minus 5 times 3 is 15. And down here, 20 is 2 times 10, and 10 is 2 times 5. So 2 times 2 times 5, and then 1, 2, 3 x's. All right, now get out my handy dandy little, let's cancel what we can. I see a 2 and a 2. I see an X and one of these X's. I see a 5 and a 5. Ooh, and this whole X minus 3 will reduce with this whole X minus 3. Remember, you can't cancel a part of one. You've got to match the whole thing, but we actually do match the whole thing. And now if you'll look, there's nothing left in the numerator, so I have to stop because I can't cancel a denominator with the denominator. So multiplying straight across, there's nothing left in the numerator, so remember we have to have a place value holder, and so that becomes 1 in the numerator. And what's left in our denominator is a 3 times a 2 times an X times an X. So 3 times 2 is 6, and X times X is X squared. All right, I'm realizing as I'm doing these that I didn't put any negative fractions in here. Make sure that you check that. If there are negative fractions, you'll need to make sure that if there's 2 of them, then your answer is positive. But if there's just 1, your answer is going to be negative. Don't forget that part, that a negative times a positive is a negative. If the signs are different, your final answer will be negative. All right, that was just kind of an extra aside. There will be some in your homework that have some negatives thrown in front of. They'll just look like this. It'll be a negative times that. And in that case, a negative times a positive would make this whole answer negative. Okay? All right. All right. I also wanted to show you one where we've got 3 factors. And that may look scary and daunting, but the truth is it's the same. It's the same thing. You just happen to have 3 of them. So I'm going to see, I think I have better space here. So this is going to be 5 times n over, remember 15 is 3 times 5 times an O and M. Be careful. All right. N and 2 are already prime. 3 is prime. M, times an M and an N. What was I thinking? And an N and an N. Now we can start going in and getting rid of things that are the same. Here's 5s. Oh, and here's 3s. And here's an N and an N. And here's an N and an N. Oh, and an M and an M. And did I get them all? I think I did. All right, I love that part, matching them up and crossing them off, because it makes your answer so simple. Actually in the book, they had a 4th step that said simplify. If you have found all of your matching factors, there is no need to simplify. You have simplified as far as you can. So I left that step out because you're going to find all of the matching factors, okay? Once you find them, you're done. So now look across, 1, 2 N's and an M. So let's put the M first just because it's alphabetical. I said M and then put mn squared over 2. That's all that's left here. There's your final answer. That's it. Done. All right, the last one, of course, I always save the hardest ones for last, and I always have to come and check and make sure you can see what I'm doing. All right, so this is one where you've got a trinomial, so you're going to have to factor out into 2 binomials. So x times x is x squared, and I'm starting to go a little bit quicker. Hopefully you're starting to get quicker at this too. 6 is either 1 and 6 or 2 and 3, but I need the difference. Ooh, they're different signs because it's negative. I need the difference to be 1, so a positive 3 and a negative 2. Over 9 is 3 times 3. X cubed is 1, 2, 3 x's. And 12, ooh, and now my first thought was, 12 is 3 times, no, this is a binomial. So we've got to factor out the binomial. So let's see, 6 will go evenly into 12 and 6. So 6 and an x will come out also. So 2 is left here, and one of the x's minus, 6x is just 1. because you've got to have a placeholder. You can't just leave it. 6x is the same as 6x, so you gotta have a placeholder there. Now, let's see. 2x, 5, and 2, nope, nothing in common, so we have to do two binomials. 2 is just 2 times 1, so 2x times x is 2x squared. And 2, let's see, we're going to have the signs are going to be the same, but the signs have to be negative, so 2 negative signs. And I need a 2 and a 1. It sure would be cool if this matched up, 2x minus 1, so let's put that there in the hopes, but remember we have to check it. So 1 times 2 is 2, and let's check and be sure. 2 times 2 is negative 4, and negative 1 times 1 is negative 1, so 4 and 1, and they're both negative, so negative 4 plus negative 1 is negative 5, so I've got it right. And I'm going to look again and make sure that you can see what I'm doing because, oh, see, I'm getting nervous. I'm getting down far enough. Okay, so now we just look for things that are the same. And once again, be careful. It would be easy to say, oh, look, I've got 3's here. I've got x's here. That won't work because I need an x plus 3. And this is not x plus 3. This is 3 times x. Not the same thing. But I can say, but look, this x minus 2 matches up with this x minus 2. And the whole thing is the same. And this 2x minus 1 does match up with this 2x minus 1. I was hoping that it would. And now, remember, this is not just 6x, this is 6 times x. And guess what I didn't do? This 6 will reduce down to 2 times 3. 2 times 3 is 6. And so now one of these 3's will reduce down. And this x, oh, look, if I use my red, you can see it better. And then it's colorful and fun, don't you know? So there we go, the x's and the 3's. All right. So now I think that's all of them. So what's left is this. X plus 3 on the top. And in your denominator, you have a 3, an x, and that's it. So 3x squared. And remember, you can't reduce these 3's because this is x plus 3. It's not times. So it's not a factor, all right? It's a binomial that must stay all together. Whew. Okay, so it's really just a continuation of what you did in the last section. It's just making it a little more difficult. That's just what I do. Add a little bit of something every time. So factor out all the parts, and then you can reduce any numerator with any denominator as long as they match exactly, and then multiply straight across to get your final answer. Easy. See you later.